Okay. Hi, everyone. Please settle down. Nice to see a full room. I wonder if it's because of the heat outside, or do you care about application sizes? Who cares about application sizes on Android? Lots of people. Is there anyone who doesn't care? Yeah? OK, great. I hope I'm going to convince you that it's really important to do that. And I also hope that you especially will go to a session tomorrow that I encourage you to all go and see Anchor and others talk about building for billions. And they're going to tell you all about building apps that will work great on all kinds of devices for all kinds of markets. But today we're going to concentrate on app sizes. And if you think, why is it important anyway? Why should I care about app size? And what is app size anyway? First of all, think about this. We're here in the US, where there's Wi-Fi on every corner, in every coffee shop. We have all those all-you-can-eat data plans. We can download as much as we want. Well, I just want you to remember there are parts of the world where people actually pay for every megabyte they download. And it's not always easy for them to install apps, to keep apps updated. And it should matter to you as developers that people install your apps, for one, and just keep them updated. And the other important thing is that people's phones not always have 16 gigs, 32 gigs of memory. So they just can't keep all the apps installed that they would want. And again, if you want users to actually use your apps, maybe you will help them a little bit by keeping your app just a little bit smaller, so they maybe will be encouraged to leave your app alone and just not uninstall it. So when I was beginning to create this presentation, I was talking with lots of developers at events. And I asked them this simple question, how big is your app? And I wonder if I ask you, just think in your head, how big is your app? Can you answer that in 5 seconds? And if you thought of a number, I'm pretty sure you thought of the raw APK size. So this is the file that is produced by Android Studio. How many people thought about that? Yeah, lots of people. And that's correct. That's a correct answer. It's technically correct, the best kind of correct. But application size is not about the file on your computer. The user doesn't really interact with the file on your hard drive that Android Studio produces. So the other important sizes we can talk about is the download size. So again, if I'm on not a very good network connection, if I have to pay for the data that I use before downloading an app, I have to actually look and think, can I afford downloading this app? Can I afford spending this much money on this many megabytes to download it? And it's not always the same as raw APK size, which we'll find out in a moment. Then there's install size. So like I mentioned, the other important metric is how much space users actually have on their devices and how much space your app will actually take up. And again, it's not that easy. So it's not always the same as raw APK size, nor is it the download size. And I'll tell you about why in a sec. And third of all, the update size. Again, you might think people download an APK. If they want a new version, they get a new APK, right? So it must be the same as the download size, only with the new APK. Well, that's also not true. Then there's other metrics, which are really, really important, like RAM footprint, how much memory your app uses, how many methods are in your app. That's really important for if you have to use multidex or not, and probably lots and lots of other metrics for app size. But we're not really going to talk about those. We're concentrating more on APK size and the 4 metrics that I mentioned in the beginning. Before we start talking about how to optimize for all those 4 scenarios, for APK size, download size, and so on, just a quick primer. Let's look at the internals, what's actually in an APK, so that we can talk about what we can do with it and what we cannot do. And an APK is really just a zip archive. You probably all know that. If you unpack it to a folder or just inspect it in a archive viewer, first of all, you will find the application code. So there's bytecode, there's the dex files. There may be one classes dex, there may be more if you're using multidex. That's pretty much all your code that you wrote, all your libraries that you imported, and so on and so on. There's also native code, so native libraries compiled for a specific CPU architecture or ABI that resides in the libs folder. And under libs, you have all these architectures. So if you have an ARM device, it needs ARM SO files, and so on and so on. Then resources, a pretty big part of your app usually. And resources are really divided into two categories. So in the rest folder, we have all kinds of resources like drawables, PNGs, JPEG files, layouts, and so on and so on. And there's also another file, resources.arsc, which contains mostly styles, identifiers, and strings. And also, this file can get pretty big. So we'll talk about how to reduce that size as well. And then there's all kinds of miscellaneous stuff like other assets. Like you put any file that you just use as a binary stream, anything that's not an Android resource. So if you want to have like a font bundle with your app or some game data, or some textures, you just put it in the in assets and you can open it later in your app. Then there's the meta.inf folder. This contains the app's APK signature. And I'm going to talk about that on the next slide. And then there's the Android manifest. So when you work on Android Studio, when you actually compile your app, Android Studio gets all pieces of information from all the libraries you use, from your own app, and it creates this combined merged Android manifest XML that finally puts in the APK. And one important thing is, if you actually do what I said and extract the APK and try to inspect this file, you will find that it's in another format. It's actually in a binary compressed format, so you will not be able to inspect it easily. And I will talk about how to do that in a sec. So APK signing. Like I said, there's a whole folder that contains the cryptographic signature for your APK. We all know that's important so that Android can verify that the app was produced by you, it comes from you, it can install it securely. And how APK signing v1 works. The important part to know here is that Android, actually, when verifying the signature, it goes file by file on every file in your archive and actually decompresses the file, then goes over the full file contents, checks it against the signature, and if it matches, then the signature verifies it's correct. So one cool thing that we can do about this is changing compression levels on files is actually allowed. So if you have an APK, if it's cryptographically signed, you can actually change compression on a file inside the archive, and that will not invalidate the signature. Another thing that's useful to know is that removing any files is not allowed. So if you remove a file, you will have to re-sign your app. And after making any changes to the archive, to the APK, remember that you have to run zip-align after any changes. So even if you change something, then sign the image, sign the APK, then you always have to run zip-align. So just a few rules. But we have this new APK signing scheme, version 2 in Android N, which changes things a little bit. So it makes it a little bit difficult, or let's say impossible, to actually change anything inside the archive. It's more secure. The signature is computed over all the bytes in the APK, so all the content in the APK, and then it's appended towards the end of the zip archive. Not exactly at the end of the file, but just before the zip archive central directory. And like I said, no changes are allowed. And what's more, zip-align has to be run before the V2 signing. So that complicates things a little bit. Fortunately, Android Studio has made some improvements, and I'm going to tell you why. But why am I talking about all this? Why did I not go straight to the point and tell you, what you can do to make your APK smaller? I think it's very important to understand those things, to understand the role of every file in this archive. For example, I said that resources.arc can get pretty big. And so lots of developers noticed that. They noticed that this file in their app takes even 10 megabytes, 15 megabytes. And they also noticed that it's uncompressed. So if you create an APK in Android Studio, and you look at the compression level of all the files, you will see that this file is actually uncompressed. So why does it waste all this space? I just said that it mostly contains strings, right? So text is compressible. So many developers, using this knowledge of APK signing v1, they go and compress this file, and problem fixed. APK is smaller. But what I want you to understand from this talk and bring as a takeaway from this talk is some optimizations are actually counterintuitive, and not always actually reducing APK size will help in the long run. So for example, in this case, compressing resources ARC is actually a very bad idea. You should leave it as is. It's optimized for runtime, for running your app, so the framework could actually memory map the file. It doesn't have to decompress it when you launch your app. Even worse, think about that. If the launcher has to read something from this file from your app, and the launcher has to read your application name. If this file were compressed, then just to show your app name next to your icon, this file would have to be decompressed into memory. So that's one thing you just shouldn't do, even though you can. And we're going to talk about all these stages and what magic things happen that make it so that download size is not always the same as raw APK size, and so on and so on. So for example, Play Store serves a compressed version of your APK. So in case, for example, of this resources file, even though we keep it up uncompressed, when it's actually sent to users' devices, Play Store will compress the APK beforehand, so we don't lose any bandwidth. We don't use any bytes over the network. So that's good. The only thing is, when installed on the device, the file will take up more space on the drive. But like I said, that's actually working as intended. Some cool stuff is also happening around install time. So first of all, remember how I was talking about the signatures and so on? You can't change anything inside the archive. And so because of that, whenever you install an app, the first and the most important part of what's taking up space on the device will be the raw APK itself. We cannot change it, even if it contains resources for other devices, for devices with different screen densities, with different CPU architectures. There's nothing we can do about it on the device because we have to keep the signature intact. So a little bit of space wasted. We can remedy that later. Then there was a thing that we introduced in Lollipop, and that was the new runtime called Art, which introduced ahead-of-time compilation. So whenever you install an APK, the ahead-of-time compiler will take all your DEX bytecode and actually compile it down into native code and store that on your, user partition. So again, this takes up space. This is a derivative of how big your code is. The bigger your code is, the bigger the compiled code will be. So another thing to be mindful about. One note, with N, we're again getting rid of the ahead-of-time compilation. We're using a JIT compiler. So this is not, let's say, not a concern as much on N devices and going forward. Finally, one curious thing. If you have any native libraries in your APK, they will actually get uncompressed, again, on the user partition, and will take up space on the user partition, so that Android can actually load them, access them with better performance. Again, we cannot touch the APK. Even though we uncompress the native libraries, they take up more space, but we cannot remove them from the APK, so that's space wasted. And fortunately, starting with Marshmallow and above, we can remedy that, and that will be one of the techniques I will talk about later. And then there's things that happen at runtime. So if a user looks up the application size and settings and looks at the whole app size, it's not just the things that I mentioned, it's also everything you create during runtime. So databases, cached images, anything you pretty much download from the internet or generate locally. We're not going to cover that as much, but remember, this is a very important part to think about too. And finally, update size. So why is the update size different than the download size? Well, I don't know if you're aware, but for many years now, Play Store has supported Delta updates, or in other words, downloading patches. How that works is, first of all, when a developer uploads a new APK on the Play Store will compute the difference, or the delta, between the old APK and the new APK. It's just basically a binary difference. It uses an algorithm to figure out which bytes are similar and how it can send only certain bytes over the network. then the delta can be additionally compressed. And finally, the client only downloads the difference, the delta file, and reconstructs the new APK on device. So the final result is as if the user had the whole new APK, the new signature and everything, but it's just reconstructed on the device from this patch file. And one thing, we've been a little bit vague about, like I said, uses some algorithm, can be compressed, and so on. And we weren't really telling you what kind of algorithms Play uses for that. And there was a reason for it. So the Play Store team always wants to improve on that. And they've been experimenting a lot. And it wouldn't make any sense to give out this information, and then it would change the next day. But actually, let me talk a little bit about the most recent Play improvements on that field. And we have a new delta algorithms. We are using BSDiff now for computing the deltas. And we've seen some major improvements for reducing this delta size. So for example, a major update to Chrome, so like a big change from one APK to the second APK, from a certain version to a newer one, used to take 22 megs or almost 23 megs on the previous algorithms. With the new one, it's down to 13 megs. With a minor update, the difference is a little bit again, from 15 megs to 3 megs. So imagine instead of downloading, a whole tens of megabytes, a whole package of Chrome, you download only 3 megs and have a new version installed on your device. From other news, we've also introduced patching and compression for the APK expansion files. That's mostly used for games, but it's super important. That's because games usually have lots of textures, huge level files. APK expansion files can be like a gigabyte in size. Imagine if from version to version you have to download and over a gig and a gig and again a gig. Lots of bandwidth wasted, and we're now saving over a petabyte of data per day for our users thanks to that. But I can talk to you developers about that. You will be happy that you have smaller update sizes and so on. But what's really important is to show the benefits to users. So starting now, Play Store will show download size instead of APK size on the Play Store. And in case of an update, users will only see the update size. So users will be more happy. They will see the benefits of all your hard work, of all the work of the Play Store people do. It's great. But Play Store is just one component, right? They can only do so much on the server side, especially with the signing that has to be left intact. So we also have some cool improvements in Android Studio 2.2, which is out in preview now. So they've been working on the whole packaging subsystem and optimizing it to create APK files that are actually better for computing those Delta updates. So first of all, they started sorting files in the archive so that things don't move around a bit, because then the algorithm, the Delta algorithms get confused and can't figure out the most optimal solution. They zero out all timestamps, zero out any empty space, like useless comments and so on. And finally, they're introducing the option to store uncompressed native code, so SO files. And I already told you about that. I will get to that later in the presentation. So what you can do if you want to actually measure if your efforts, if what Android Studio is doing any good for your update size. And I'm happy to say we finally released a tool that will help you estimate, and let me stress that, estimate the update size. Again, there may be new algorithms, there may be experiments that are going on, but this will give you a good estimate on the current algorithms and how they work for your APK. So basically, you run it against an old APK, a new APK, you see the size difference, and you can see if any changes you make sense for that. So now, moving on to the second section, which is kind of like a tips, recipes on how to actually make your APK smaller. And let's go through some of those things. And first of all, how many of you had read my articles on Medium on keeping APK size low? Some of you? OK, so let me first explain one point of contention about using Zopfli compression for APK. So in the articles, I actually wrote that you can reduce the size of your APK just by using a better compression method. It's called Zopfli. It's an algorithm that was created by Google engineers. And yes, it did make your APK smaller by a couple of %. Nothing much changed for like users. They were decompressed just as fast and so on and so on. But currently, we advise against using Zopfli for your APK. So first of all, some users did write to me saying that certain devices and certain versions of Android might have had a kind of problem with Zopfli compressed APK. Like they just threw an exception. So that's one thing. Another thing is they take an awful lot of time to compress on your computer, which, well, you don't make a release, every 5 minutes, so it's not that of a big deal. But the next thing is really, really important. So like I said, the Play Store team likes experimenting with stuff. And actually using Zopfli, because it's so resource intensive and it needs so much CPU and memory to compress, it might actually, in the future, it might actually make new kinds of differential updates impossible. So if you read my articles, if you were thinking of using Zopfli, forget about it, just don't. Especially since the new packaging system in Android Studio actually experiments when compressing files in your archive, and it actually figures out the best gzip compression for the files. So that's also something new in Android Studio 2.2. Next, images. How many of you have been to Cold Session just before? Yep. So I'm just going to do a quick recap. Remember that you can always pre-optimize your images. The tools that we currently have in Android Studio in our build tools don't always do the best job of figuring out the best compression for images, the best optimizations they can make. So you are free to use external tools to pre-process images in your drawable folders. They might be a lot smaller from that. And just remember that you used to have to add these lines to your build.gradle. That's simply because, again, the packaging system had its own optimizer, and it wasn't, let's say, smart enough to figure out that if you pre-process an image, then our build tools process it again, they could actually make it a little bit bigger. So this actually disables crunching of images so that your pre-processing is left intact. I'm happy to say I've talked to the people at Android Studio, and they promised me this will be fixed for Android 2.2, so the build tools will be smart enough to figure that out. One very easy win you can have with your PNG images is actually Zopflify them. So again, this better compression algorithm called Zopfli turns out it's OK for images. You can use it for PNG files. There's tools that do that for you. It's completely lossless. It doesn't change anything. The images look the same. They work as fast. And it's an easy win for file size. WEBP, it's another image format developed at Google. Gives about 30% smaller image sizes than JPEGs, for example. And you can use WEBP for your images again. Just remember one thing. Support for WEBP was added in Android 4.0, but only to replace JPEGs or PNG images with no transparency. And that's because only Android 4.2.1 added support for new WEBP formats, including lossless and transparent. So then you can replace all your PNGs. And also remember to use it server-side. This is really the biggest win, because if your app downloads a lot of images, if you know it's on Android, your server can just generate WebPs instead of JPEGs. You will send your users a lot of bandwidth, and you will save a lot of space on the device if you cache those images. If you can, on Android 5.0, of course, use vector drawables. It's a great text-based format. It compresses very well. It's just amazing for icons. If you're targeting still Android, previous versions of Android before 5.0, there's two ways you can actually use vector drawables. So for some time in Android Studio, we've had support for generating PNGs from your vector drawables. So if you put vector drawables in your drawable folder and add these lines to Android Studio, it will, during compile, during building your APK, it will actually generate those PNGs for you, for those older devices who cannot use vector drawables. And after that, we finally got vector DrawableCompat. So that's a more programmatic way of using it from the support library, where you can actually use vector drawables on your image views in code. It just works. Of course, there's a little bit more to it, but for that, I suggest you go to Chris Bain's session, where he will probably talk about that. And finally, shape drawables. This has been in Android since 1.0, and I think it's really underappreciated. So, vector drawables are great. You can do lots of complex shapes in vector drawables, but they're not always available, like I just said. Shape drawables, however, have been there forever, and they're great for simple shapes like button backgrounds, borders, gradients. They're super optimized, super performant. So if you can use a shape drawable, just please do. And like I said, this was a quick recap of what Colt was talking about an hour ago here on this stage. But since everything is recorded, I encourage you, those of you who haven't been able to attend the session, or those of you watching online, to go and check out his session on image compression. So that's what we can do to resources, right? But what about code? And really, with your code, with the size of your code, there's one thing I want to tell you. Use ProGuard. You will hate it, but use ProGuard. Please do. It's very easy. No, really. It's very easy to add to your build Gradle file, and then things will break. So yeah, just add this line. There's also a new way of using the built-in shrinker in our tools. So you can, if you do minify enable true, that enables ProGuard. But you can then go and actually say use ProGuard false, and this will use our built-in shrinker. That's a little bit faster, but it doesn't do all the things that ProGuard does. So it just removes classes. It doesn't obfuscate, but it works better with instant run, for example. But anyway, whichever option you decide to use, you then have this notion of ProGuard configuration files. And by default, we have one in the SDK, which has some same defaults for any Android app. So for example, the built-in ProGuard file already has rules that keep all the setters and getters on your view so that animations work and so on, because otherwise they would be optimized away and your app would break. But then if you're not familiar with ProGuard rules, it's a really complex topic. I will not teach you that here. But you can go and look in your build folders in the Android Studio. There's actually an auto-generated file. It's generated by AAPT. And it looks at basically at your Android manifest. It looks at your layouts. And it generates rules for your activities, for your views that you use in your layouts. And again, by looking at those and by looking at the default ProGuard file, you can learn a lot and start writing your own. And there's also another easy way. If you know that you're doing something in your code that will be optimized away because you access it by reflection, for example, there's a new way. Just add an annotation, use the new build tools. ProGuard will just leave it as is. It will not be removed from your code. If you're writing libraries for other users or just libraries that are components in your app, sometimes those libraries just need their own ProGuard rules so that when someone uses them, they don't break their app. And just remember, be a good citizen. If you're writing a library, if it needs ProGuard, you can put your own ProGuard configuration inside your library, and then anyone who imports it, it will just work. But not always you can't always remove code because you don't need it. So sometimes you actually need the things you're adding to your project, but it's not easy to keep track of all the libraries that bring in other libraries and so on. So we call these transitive dependencies. And if you add just one dependency to your build Gradle file, it may bring in lots and lots of those transitive dependencies. So if you weren't aware, there's a cool command line command for Gradle will let you see a tree of all those dependencies that you bring in with your libraries. And here, the only advice is just be aware of what you're using and what kind of libraries you're pulling in, and make the right decisions by looking at this. And if you're still not sure if what's inside your APK, what kind of classes, finally make it through the ProGuard, through the optimizations, through pulling in other libraries, there's a tool that we open sourced recently called Classy Shark, and it's basically an APK explorer. So it will let you go into your DEX files. It will show you all the packages. They're great for debugging ProGuard, and you will do that a lot if you enable it for your app, let me tell you. And I really encourage you to try it. So we have ProGuard for bytecode. But if you go through this, this pain of enabling ProGuard, you actually get one more very important thing, and that's the resource shrinker. And once you have ProGuard enabled, you're going to get another option called shrink resources true, and that will go and figure out which resources in your app are actually referenced from the code that is left after ProGuard runs its course. And it can remove any resource that is unused in your code, which is pretty awesome. And again, it has a configuration. So you can add this really on any resource file, on any XML resource in your resource folder. Just add this tools keep or tools discard attributes. And you can make sure that if there are resources that you want to have in your APK, or if you explicitly want to remove something from your APK, that's where you configure it. So a little bit like ProGuard rules, only for resources. And then sometimes it happens that if you pull in a library, even like Google Play Services or the support library, we offer translations for many languages in those libraries. But what if you're making an app just for one market, just for one language, or just for 2 languages? If you know that there will be no users of your app, or that you don't manage translations for other languages, then you don't really need all those resources from those other libraries, like the support library, for all those other languages that you do not support. So just use resConfigs. Just put the names of the configurations or the languages in this example that you want to make it to your APK, and the rest will be simply removed. And one side note here, there's a lot of tips on Stack Overflow and other places about using this for stripping resources for other densities. That was supported a long time ago in ancient versions of our Gradle plugin. You can't really specify many densities here, so don't use it for densities unless you specify only one. But that's kind of a very advanced usage. So we have resConfigs for resources. We have shrink resources, ProGuard. But there's one very, very advanced technique that probably not many people are aware of, and that's the problem of sparse resource configs. And so if you notice that your resources.arc file is bloated, it's very big, but you don't know why, it's worth trying to figure out if maybe that is your problem. And let me try to explain that. It's not very simple. So I'm not going to teach you how the resources file format works. Let me tell you, this is a big oversimplification, but hopefully it'll get the point across. So imagine you have an app that has 5 strings. The strings are somewhere in a string pool. They take up some memory. And then you have your default config. And you have your string, my app, hello, exit, and so on, just labels for things in your app. But then you decide, well, I'm adding a new feature to my app. It's going to be named new feature instead of feature. So you get a new string, right? But this new feature only works for version 21 and above. So you have a config. You create a new folder under your resources with v21, and you're just switching this feature to new feature in that config. Well, it should take up only space for one string, right? But it actually has to keep null entries on all the positions for other strings that you're not using in this config. So you lose a lot of space. It still takes up a lot of space, even though you're just using this to override this one string. And I know these kind of bytes, who cares about bytes? But if you think about that, if you have an app that has 3,000 strings, if you have 50 translations, And there's a lot of apps, like among the top 100 apps on the Play Store, I'm sure lots of them have even more than that. The cost of adding a single string for V21, for example, that's translated for 50 languages would give you 600 kilobytes overhead. And that's something we can work with, especially if we can have lots of other dimensions than just V21. You can actually shrink your file a lot. But how do you know that you're doing this? It's not very easy to guess, like, which string do I remove? And we just recently open sourced a tool called ARC Blamer. It's on GitHub. I'm going to post those links later, don't worry, on the Spaces application, on our Space for this talk. And basically, it's a command line tool. You run your APK through it, and you get a CSV file. You upload the CSV to Sheets or use some other program for that. And it gives you this kind of nice overview of where the resources are in your application. And if you sort that by the null entries column, then you can find which configs are the most sparse in your app. So which configs waste the most space. So in this example, if you look at the rightmost column, I can identify that the string that's called apps list is wasting almost 200 kilobytes in my app. Well, 200 kilobytes is not a lot, right? But the next one, if I remove descriptive text 1, I'm saving 1 megabyte from this file. And you can do this over and over and remove a lot of really unneeded data from your resources. And some of our apps, I want to say, remove 2.5 megs by removing just 3 strings. So that's pretty big savings. So that's that. Let me just say that it really works for only big apps. If your app is not really huge with lots of configurations and so on, then probably you won't get anything from that. And finally, getting to the native libraries that I mentioned so many times already. So since Android 6.0 Marshmallow, we have this attribute that you can add on the application tag in your manifest. Extract native libs false. And basically what it does, it instructs the package installer, the system, to not copy out those SO files, the native libraries, at installation from your APK. And the other thing is, things just work. So if you're using system load library, you just don't have to think about it. The APKs will just, the SO files will just stay inside the APK. They will just work. You don't waste this space that's used for decompressing them somewhere on the user partition. But there are conditions. For this to work, the SO files have to be uncompressed in your IPK. And the other thing is they must be correctly page aligned using zip align. So up until now, there was no easy way to do that using Android Studio and our tools. It was just not supported. You have to go and manually decompress those files and store them and so on. I'm happy to say that Android Studio 2.2 finally does that for you automatically. So you can enable this option in the Android manifest and see big gains. If you're worried that having an uncompressed SO files will just bloat your APK, will make it really big, that's true. Raw APK size will go up a bit. But remember, the Play Store compresses data anyway, so the download size will not suffer. And the delta sizes will actually be smaller. That's because the BSDiff algorithm will be able to figure out smaller deltas for uncompressed SO files. So win-win-win. Just a little bit bigger file, but we can live with that. And then I mentioned before that there's not much we can do on the device with resources that are not targeted at your device's, let's say, screen density. And if you produce a fat APK, if the resources are all there, there's not really much we can do about that, unless you actually split your APK into many smaller APKs targeted at those devices. And Android Studio supports producing two kinds of split APKs. One of them is density-based, so you can actually, during your compilation, you get smaller files with resources targeted at specific screen densities. Then you can then upload to Play Store and use the multi-APK feature to serve them only to certain devices. And then there's the ABI-based multi-APK. So again, if you have native libraries for all kinds of CPU architectures, that will usually be really big, a really big portion of your APK. So again, you can split those. You can have multiple APKs that you can upload to Play Store, and the users with devices with a certain CPU architecture will get only this file that's suited for their device. The only thing you have to remember is every APK has to have a different version code. So there's some scripts that you need to add to your build APK to make that work. I really encourage you to go and see my articles on Medium where I have the necessary snippets. There's really no time today on this session to go through all the code variants for that. And example density split savings, I just took our Topeka sample app. It's really image heavy. So again, results may vary, but the original FAT APK was 3.5 megs. And then if I split that for different densities, it's almost 2.5 megs saving for everyone. And then you can do a lot more. You can do custom multi-APK. You can split things by min SDK version. So we have, if you have some features that only work for 21 and above, maybe it's better to start thinking about splitting those up. That's pretty advanced stuff, really. So not everyone wants to do that. Then for games, you split by texture formats. You don't have to ship all textures to every device. You can recreate density and ABI splits using variants in Android Studio and customize it even more. And then for games mostly, you will use APK expansion files to put all this stuff that you can't fit into the APK to a separate file that will be downloaded from Android Studio. And here's an example of this file, of a build Gradle file that kind of recreates the splits using multi-APK. Again, I encourage you to look at my Medium articles, and this will be explained there better. So what's next? Go through my articles, go through the tools that we have, and since we have only 3 minutes left, let me just mention that some of the tools that I mentioned during this talk, we are actually building those into Android Studio. So you might have heard at the keynote that there's a new APK analyzer in Android Studio. So I'm happy to say you will be able to download that now and play with it. And what this actually does, it shows you the compressed size of your APK. It shows you the compressed sizes of every resource inside your APK. You can browse classes in your DEX files. You can browse resources, a little bit like ARC Blamer. And then you can also look at Android manifest XML as it is in this form that is compressed in the APK. So I encourage you to try it. It's still under development. It's an early preview. If you have any feedback, if you find you think you'd find some feature that's missing useful, please contact us, and I'm happy to hear your feedback. So thank you very much, and I will be open to questions.